Here we have a Caesar cipher, which is one of the simplest encryption techniques that you can use because it only shifts the alphabet letters by a set number to encode a message. So in this particular scenario, what I've done is I built this all into a tool that allows you to not only create the cipher and encrypt the cipher, but also to use statistical analysis to detect what the cipher probably is. So if you can figure out what the shift most likely is, and you can come up with, let's say, some kind of a metric that looks at the highest probability for what the shift is, then you could actually detect what the message is. And you could even think of this as a technique you could use if it was a big data problem, for example, and a lot of the data was using this Caesar cipher. Before you tried every single approach with a brute force, you could actually sample it like I'm doing in this particular example. So if we take a look at this, we can see here that there's a shift here of 10 in this particular example, and I can go through and try to guess exactly what's happening, and it'll give me different scores. So in this one, it'll say shift 0, shift 1, shift, etc., etc. And you can see here that there's two that are pretty close here, and there's another one, shift 11. And if we keep going down, though, even further, shift 16 has got a tremendous score, which is a score of 40. So most likely, based on this statistical guess of the frequency of the letters, that shift 16 is going to be the one that's used. And if we go back up here, you can see here that you can actually try that out. So here we're going to tie it all together. First, I use command line tool library, which is the parser. Then I go through and I print the analysis, and then I pull together different items like the message, right, is a key component, the stats here, statistical information about the message, and then guessing the shift. And then you, at the very end here, pull this all together into some code. Now, if we look at the lib, this is where a lot of the magic happens here, is that I have a hash map and I store the initial frequencies of letters. So if you look at 80% of the letters in English, they're going to have this particular makeup. So E would be 12.7, T would be 9.1, A would be 8.2, etc., etc. And then if we go down here, we could actually come up with a statistical analysis. So we could look through what's going on in the code and essentially map out the probabilities. And then finally, we could print out the statistical analysis inside. And that's what this function actually does. Finally, if we want to decrypt it, we would just then pass it in to this particular function here. So really, that's the genesis of everything that's happening. And then if we want to guess the shift here, what we would do is we would use a statistical analysis to determine the likely shift, and then we would actually return back what most likely is the decrypted message, because it would pick the highest score. So here we can see how all that works, and then we return back a guess shift. So this is like a secret decoder ring that is going to do its best to guess what's happening. So in order to use it, all I need to do here is go ahead and do cargo run. And then if I do dash dash and then dash dash help, I can get some feedback of exactly what's happening. When we first start off here, it's going to say, okay, CLI tool to reverse engineer a Caesar cipher. Okay, great. So let's go ahead and do a message. And we can say, for example, the message would be hello. And then we would put in this particular example here, what some kind of statistic. If we wanted to, we could do, dash dash stats, and it would say, the frequency. Now, because I want to work on something that's already encrypted, let's go ahead and go back to, here, and let's figure out a message like this, and let's just put this message into our tool. So we can actually even put it all together and make it easier, and go to a guess, and we can see here that it's going to run through the tool, and it's going to look through every one of the different scores that's generated, and it found that the highest score is 16, so it's going to try to do 16, and it's going to say decrypted message, which is off to the bunker, every person for themselves. So really, this is a great way to try out different ideas with ciphers, encryption, is to put it into command line tool. And also, we know that one of the weaknesses of a cipher is the fact that it's vulnerable to this frequency attack, right? So we know that if you analyze the letters in a cipher for frequency, that one of the giveaways is that the letter E is used 12% of the time, 12.7% of the time. So you know that you can start to do these guesses and then actually calculate what the score is. And then that's really the way to essentially decode the message using statistics. So kind of a fun exercise to play around with. And it was all made possible by the elegance of the